Okay, guys, hello, and this is Abhilash again, and we are now going to look at the next program in our syllabi. So, the next program is on an ALP to determine whether the given 16-bit number is an even number or an odd number. You just need to find whether a number is an even number or an odd number. So this is a very significantly simpler operation, and we are again going to go through the same two steps as we did in the other experiments. We are going to see what is the logic for finding out whether a number is an even and an odd number, and after that we are going to see how to implement that logic in the assembly level program for an ARM Cortex M3. So let's look at the logic itself first of all. So initially, let's take an example of a decimal number. The number that we are looking at is 24 in decimal, which if you convert to binary, if you convert to hexadecimal, is going to be 18, right? So from the hexa, you can directly write the binary, and this is the binary number that you are going to get. Now, this number is your 18. To verify, this is 1 and this is 8. So that basically is your direct representation of hexa in a binary string. Now, the same way, taking number 25, 25 now is then obviously going to be 19 in hexa. So this is 1 and 9 in binary for us. Now, this is the numbers that we are going to take, and specifically I have chosen 24 and 25 so that we have one even number and one odd number in our example. Now directly comparing these two, you can see that the difference of being even and odd will always lie in the end LSB. That is the LSB which has got 2 to the power of 0. So if this LSB bit or the 2 to the power of 0 value, if this bit is representing a 1, then it is an odd number. If not, it is an even number. So the weightage of 1, which makes a number odd, is given by the LSB bit. So if this bit is 1, then obviously it's an odd number. If not, it is going to be an even number, because all the remaining weights are powers of 2's and they have to be even numbers. The only odd number in this entire binary conversion, in the binary level, is from the LSB bit, that is the 2 to the power of 0 bit. So we only have to check the LSB bit to find out if a number is even or odd. That's as simple as it can be. So we are going to use again a rotate operation, and we are going to check that logical rotate operation by rotating the value into carry, and we are going to check if the number has got a carry or not after the rotation. So if there is a carry, then it simply means that the LSB bit is 1 and that is an odd number. And if there is no carry, that simply means that the number is an even number. So you only have to check if there is a carry or if there is no carry. More importantly, to identify whether there is a carry or not, what we are really going to do is we are going to move or set one register. We are going to use one register with some specific value, which will tell you that if this value is stored, then it's an odd number. If this value is not stored, or if the register is empty, then it's an even value. So some logic like that, let's implement. Now this will become a very simple code. The almost the same portions that we have done, the C program we will call. Then in within the C program, this assembly level program will have to be called. And in the assembly level program, we are going to use register R0 with the value that you actually want to check. So R0 is the register into which we are going to load the value which we are going to check for even or odd. And once that is done, we are going to shift R0 by one time to a logical write. And once that logical write shift happens, the LSB bit is going to be loaded into our carry register. So you are simply going to check the carry flag. If the carry flag is set, then R3 will be incremented. If the carry flag is not set, then R3 will be decremented. R3 will be unchanged. So this is the logic that we are going to use. This is the simple program that we are going to use for finding out if a number is even or odd. So now let's see how this program is really going to work. So I have already typed our program somewhere. Let me open it. Okay, so this is the program, I guess. Yeah, so there is a small thing here that I had to modify. If you don't clear R3, we will have difficulty in finding out if the number was added or not. So to make things simpler, what we are really going to do is R3 is going to be cleared, and also the number that you can load into R0, you have to be careful. It cannot be a very large number. You should you keep a smaller number to make things simple. So I have just loaded the hexadecimal 11 into the number here, and from this I am simply going to find out if the number is even or odd. So hexadecimal level 11 basically means that we are looking at this number here. This is the binary equivalent of the number that we are going to use. Now, this number we are going to load. R3 has to be cleared. After that, you do a logical shift. So, when you do a logical shift, 1 is there which will get loaded into the carry flag, and R3 will be incremented, or R3 will be incremented, set to 1. So, if R3 is set to 1, that means this is an odd number. R3 is set to 1 means whatever R0 has is an odd number. If R3 is set to 0, then R0 is actually having an even number. So this is the logic that we are going to use. I am going to remove these two. We don't need any kind of loop here. So this is enough for us for doing the program. Okay. So let me save this, and let's build the whole thing again. Okay, so zero errors, no warnings, and some warnings, and let's put it into debug mode. Okay, so to show you for the very first time, I am going to simply put a breakpoint before the rotate instruction. So now what we are supposed to do is when till here, by the time it executes, R0 will have 0x11, R3 will have been cleared. So let's see if that really happens. Yeah, so R0 right now has got 0x11, and R3 has actually got cleared. Okay, so now let's go ahead and complete the execution. Now, once the execution has completed, you can see that it has come and got stuck with the while loop. So that means what has really happened here? R0 has got shifted by 1 bit. So 1 has come to this place, this one has gone to carry. So this has become 08. And more importantly, R3 has been incremented because 1 had gone into the carry. It has detected the carry and incremented the value of R3. So if R3 is containing 1, then the number is an odd number. That logic of ours is working. Let's check if it works with an even contingent. So now I am going to make this 1, 2. So when I am saying 1, 2, what really happens is this number is going to become like this. So this is an even number for us. Let's check if things work out there. I'll rebuild the target again, and let's put it into debug mode. Yeah, so I have set the breakpoint somewhere. Yeah, I have set the breakpoint here. Okay, so let me run again. So now again 12 has got loaded, R3 has got cleared. The execution, let's see where it goes. Okay, so now you can see that R3 got cleared and R0 got loaded with 9. So this shifted to by 1 position and that got it loaded with 9. So that simply is saying that the value here is odd or even. So this is a very simple way of doing this. You can find more creative ways of doing the same program. I would suggest that you could try loading R3 with 00 if it's an odd number, and loading R3 with FF if it's an even number. So why don't you try writing a code to do that? Try writing a code to uh, load 00 in case the number is even, and FF in case the number is odd into R3. Okay, so with that as a small exercise for you guys, I think I'm going to wind up this video. Bye bye, take care.